Hello everyone. Today we were talking about area and perimeter in a coordinate plane. Right now I want to do some examples with you of composite figures. Remember, a composite figure is just a polygon that can be broken down into smaller, simpler shapes, other polygons, such as rectangles, triangles, simple things that we know formulas to. You should have already taken your notes based on what was posted in Google Classroom. Hopefully, you've already given the 3 examples a try, and now you are double checking with me and my notes and how I did the problems. Problem number 1. Problem number 1 gives us this pentagon A, B, C, D, E. It's a weird looking shape. I don't know a lot about it right now, but I've already broken this one up for you a little bit. If we were to divide this shape, we can cut it into smaller shapes, smaller polygons that we already know how to find area of. When I look at this polygon right here, I notice that we can cut it, I can divide it right along this segment that connects AC. If I use that cut right there across that segment AC, well, I notice that I've now created a triangle, ABC, that is fairly easy and simple. We know how to find the area of that triangle. That's easy. If I continue to cut the polygon, if I cut it down this segment right here, GD, I created 2 more polygons that we know how to find area. We created another triangle over here, and we created a large rectangle over here. Area addition postulate says that we can find the area of each smaller individual polygon, add them together to get the total of our large polygon. So that's what we're going to do now. First, I'm going to start with triangle ABC. That'll be the first work I do. Triangle ABC. Well, I know to find the area of a triangle, the formula is base times height over 2. So I need to use my coordinate plane, use my pink triangle to find the base and the height. The base, super easy. Count. 1, 2, 3, 4, 5, 6, 7, 8. 8. The height must be perpendicular to the base. I illustrated that segment right in there for you, that segment BF, that is perpendicular to the base. The height is 1, 2. Do some simple math, use our area formula. 16 divided by 2 is 8. The area of the pink triangle on top of our figure is 8 square units. Continuing on, now we will work to find the area of our yellow triangle right here. Fortunately for us, if we look closely at our coordinate plane, it is a right triangle again. Triangle CDG. CDG. Base times height divided by 2. It's a triangle. Let's see, the base. I'm going to count this segment right here. GC is the base. 1, 2. The height, GD. 1, 2, 3, 4. Over 2. 8 over 2 is 4. Easy. Last polygon to figure out to find is this rectangle over here. Rectangle AGDE. AGDE. Find a better color. The area of any rectangle is base times height. Fortunately for us, our rectangle is orientated very nicely on the coordinate plane. Base 1, 2, 3, 4, 5, 6. The height 1, 2, 3, 4. 6 times 4, 24. Now that we have found the area of each smaller individual polygon that's made of this large pentagon, we add all three together. 8 plus 4 plus 24, 36. 36 square units. This pentagon A, B, C, D, E has an area of 36 square units. Example 1 done. Example 2. Another find the area by addition problem. Again, we want to cut this into the easiest possible smaller shapes we can. As I'm looking at this, the first division, the first cut I'm going to do is right along the y-axis right here along E to G. I cut that segment right there. Gives me a triangle I can work on. I continue that cut down the y-axis, and I created another triangle. I'm going to make one more cut. This time I'm going to follow the x-axis, and with that cut I have created a triangle below it and a rectangle, a square perhaps, above it. This time, to find the area of our composite shape, this weird looking shape, D, E, F, G, H, I, J, we're going to find the area of the 4 parts. Call this part number 1. Triangle EFG. Again, triangles, base times height divided by 2. This time I'm going to count the base as EG, the red cut I made. 1, 2, 3, 4. And I'm going to create the height, insert the height, by finding the perpendicular to our base. Fortunately for us, that's very easy to do on this triangle. 1, 2, 3. 12 divided by 2 is 6. First area done. Second area, pink triangle down here at the bottom. That would be triangle GHI. GHI. Triangles, base times height divided by 2. We were fortunate that we cut ourselves a right triangle. 2 for the base. 1, 2, 3, 4 for the height. 8 divided by 2 is 4. Third triangle. Triangle G, I, J. G, I, J. Excuse me. Area is base times height divided by 2. I'm going to use the x-axis as the base. 1, 2, 3, 4. The height going down. 4. 4 times 4 is 16, divided by 2 is 8. So far, so good. I've accomplished the 3 triangles. Now we need to find the area of our last shape, the rectangle or square perhaps up there. Excuse me, that's number 4. We would call that D, E, G, J. D, E, G, J. And the area of any rectangle, any square, any parallelogram is base times height. We see right angles everywhere on our coordinate plane. Makes it a very easy one. The base, 1, 2, 3, 4. Same measures at the bottom. The height, 1, 2, 3, 4. Same measure on the other side. Since we just saw that both sides are congruent, we see on our coordinate plane that all 4 corners are right angles. The segments are perpendicular. This is definitely a square. We just proved that. 4 times 4 is 16. Now, I've found the area for every part of our composite figure. Now we need to add them. Six plus 4 plus 8 plus 16, 34 square units. The area of D, E, F, G, H, I, J is equal to 34 square units. Finding area by addition is a very simple thing. Find these small areas, add them up. If we can find area by addition, we can also find area by subtraction. Areas by subtraction. Consider a shape like this. It's a little bit harder to divide this one because any divisions we would make if I was trying to make a rectangle or any triangle, they don't follow the normal coordinate grid lines. If we have a shape, a polygon, that does not follow normal grid lines, finding the area by subtraction may be easier. To find the area by subtraction, I'm going to take our polygon and I'm going to build a square or a rectangle around it. From each side, XY for example, I'm going to construct a right triangle. Always use the widest side and the lowest side to help you construct. Continue on. WX. Constructed another triangle. YZ. And lastly, WZ. If we do that, we've constructed a rectangle around our polygon. Our rectangle has a base of 7. 1, 2, 3, 4, 5, 6, 7. Double check it on the top. It has a height of 1, 2, 3, 4, 5, 6, 7, 8, 9. The area of our very biggest rectangle here our 9 by 7 base times height rectangle. 9 times 7 is 63 square units. Now that we found the area of this large rectangle, we are going to find the area of the 4 triangles we constructed and subtract them from our 63. We're going to find the area of this triangle, this triangle, this triangle, and this triangle here. Fortunately for us, because we used our coordinate grid to construct these triangles, each and every one is a right triangle, and that makes our math much nicer. Let's start with this pink triangle, call it triangle number 1. It's 2 wide, 1, 2, 3, 4, 5, 6. 6 tall. Base times height divided by 2. 2 times 6 divided by 2. 6 units for the first pink triangle. Second triangle over here. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 5 by 5 triangle. 5 times 5 over 2. 25 over 2. 12.5. Third triangle, blue one down here at the bottom. 1, 2, 3, 4 tall. 1, 2, 3, 4 wide. 16 over 2, 8 square units. Lastly, this yellow triangle down at the bottom. 1, 2 units as the base. 1, 2, 3 units tall. Six over 2 is 3. Excuse me, I made a mistake. This is not 3, not 2, it is 3 wide. Should color in that little corner so I don't make any more mistakes. Try that again. 3 times 3 over 2. 9 over 2 is 4.5 for the last triangle. Now that we have found the area of the 4 right triangles, the 4 corners that we constructed, we can add them up. 6 plus 12.5 plus 8 plus 4.5. That should give us 31 units, square units. Now, we found the area of the largest rectangle that we constructed along the outside. We found the area of each individual triangle we constructed around our polygon. To find the area of our polygon, of our quadrilateral, Z, W, X, Y, or any order that you choose to go, we have to take our 63 units we found from our largest rectangle, subtract the sum of our 4 corners, the triangles we constructed. The difference, what's left over, will give me the area of our original polygon, X, W, ZWXY. I hope this video helped explain finding the area of composite figures. Good luck. We'll see you on Monday.